My name is Srinath Krishnaswamy. I manage the Data Access Group, Development Group at Oracle. And here with me today is Kwasi Mensah, who is our product manager. We are part of the database division in Server Technologies Group. And my team manages the various Oracle C and C++ programmatic interfaces, including Oracle Call Interface, popularly known as OCI. Anybody familiar with OCI? Great. My team also owns the ODBC driver, the precompilers, the Oracle C++ call interface, also known as OCCI. We also provide the data access infrastructure for other Oracle drivers such as the JDBC, the thin JDBC, the Type 4 driver, and the ODP.NET driver. We also contribute to the open source drivers. We have been making enhancements to the PHP OCI 8 driver in uptaking some of the key database features. Recently, we have also taken, we've been actively contributing to the driver for the R statistical language. It's called R Oracle. And my team also owns SQL+. We are actively engaged in developing solutions which enable application developers to build highly performant, scalable, and available applications. And so my talk is going to be focusing on those focus areas. So this is the standard disclaimer. So in this presentation, I'll be talking about the best practices in database access to achieve high performance. I'll be presenting the use of performance tools by which you can identify performance issues and solve them. Following this, I'll be talking about high availability features. Throughout my presentation, I will also be talking about the new Oracle Database 12c features, which have made significant advances in the areas of performance, availability, and scalability. I have a lot of slides to cover, so I would like to take questions at the end of the presentation, but if anything is not clear, please feel free to stop me and to ask me to clarify. So this slide lists the new database features that we have in the various focus areas. Like I said earlier, I will be going through each one of them during the presentation at an appropriate time. So there are quite a few new features, enhancements that we are all excited about. So the first section is performance. So in the performance section, the focus of my presentation is not about SQL tuning, nor is it about Oracle database tuning. It's more about the best practices that you would use to achieve high performance. And I will also be talking about, like I said, the performance tools that you can use to identify performance issues and solve them. The performance best practices apply to the various stacks. This slide shows the various languages and the corresponding Oracle drivers. The best practices that you will hear in this presentation apply across these stacks. So you can, using these concepts, one can use it in the language of their choice. Some of these drivers are provided by Oracle, and there are some open source drivers also. So performance tools. Two of the tools that we have are built right in the database. The first one is the Automatic Workload Repository, also known as AWR. AWR was introduced in 10G. It's an evolution of StatsPack, which existed prior to 10G. And AWR captures key performance statistics from the database perspective at regular intervals. So by looking at this, by inspecting these statistics, one can know what exactly was the database activity a particular workload did. And we will be looking through the AWR report and ADDM reports during the presentation. The next one is the automatic database diagnostic monitor, also known as ADDM. So it basically looks at the AWR snapshots. It reviews it and basically comes out with recommendations. So it comes out with specific recommendations. So we'll go through how exactly this can be used. Again, the purpose of these tools is to try and eliminate some of the guesswork in terms of identifying performance issues. So getting the ADDM and AWR reports, the way you would start out with is, you would first start out by creating an AWR snapshot. And then you would run the workload. And following that, you would take another AWR snapshot. And then using the Oracle provided scripts, you would then go through the process of generating the AWR report and the ADDM report. So these are fairly straightforward to use, but they provide a kind of a good inspection tool on what exactly the database was doing when the workload was executing. So before we talk about the best practices, one thing that I wanted to also bring up is that in Oracle Database 12c, we have provided new deployment tuning capabilities for OCI and OCI-based applications by the introduction of a new configuration file called Aura Access. This is an XML-based file. This allows you to specify the various database access parameters that you could previously only programmatically specify. So this, using this tool, you can, at deployment time itself, try and tune your application. And I'll talk about some of the parameters that we have introduced in 12c. And this will be ongoing, that is, we'll continue to enhance in terms of the number of parameters that this will support. But this is a step in that direction. So once the parameters are specified here, it will override the programmatic settings. And there are two classes of parameters. Some of the parameters are process-wide and others are connection-specific. The process-wide parameters include high availability parameters. If you have used the high availability feature of OCI called fast application notification, you would know that you would have to programmatically enable events to be able to get these notifications. But now at deployment time, you can turn on the knob events by which you can start receiving HA events. The client result cache parameters, you are able to tune the size of the client result cache parameters and the various other parameters in this file. And there are also diagnosability that we have introduced starting 11GR1, the diagnosability parameters to diagnose a running application. So those parameters can be set.
I have a question here. So this, you are talking about this on the client side?
In the middle, yeah, that's correct. There's a new feature that we'll get into called auto-tuning, and one can specify the auto-tuning parameters in this file. Statement cache and prefetch. I mean, these are parameters that existed, but you could only specify it programmatically, and now we are enabling you to specify it at deployment time. ONS configuration, so this is something that is new in 12c. So OCI and OCI based applications will use the Oracle notification service for their HA notification transport. So those configuration, we also made it very easy to configure ONS, and so that can be specified through this deployment, the Aura Access configuration file. So the parameters can be classified as the default parameters. So the structure of this the file is that you start out with the default parameters, which include process-wide and connection-specific parameters. So if you want to apply these parameters to all the connections that your application is going to be creating, then you could just specify it at the default level. If you want to override for specific connections or group of connections, then you can create a named group of parameter list. So that's where the configuration description comes in. And the next section is the configuration mapping, wherein you can associate a connection, either a explicit connect string or a easy connect string or a TNS alias. You can associate that with a named group that you can create. So I have an example. So this one shows the default parameters. So like I said, the events parameter, which is a HA parameter, which can be enabled here. That is process-wide. The client result class parameters, you can specify that's also process-wide parameter. And then you can have connection-specific parameters such as prefetch and statement cache. We'll also get into the details of prefetch and statement cache further down, but if you're familiar with these concepts, you will know that they take in a size value that you can specify in this configuration file. And if you want to override the default values for a set of connections, you can create a named group. So in this particular case, we are creating a named group called foo, and in foo we are saying that the parameters for any connection that is associated with foo will get a prefetch of 100 and a statement cache size of 30. And the section below shows the connection config. So here you are associating the alias, the TNS alias HRDB with the configuration foo. As far as the location of this Aura Access file, we use the same search path as SQLnet.aura in locating this configuration file. So we talk about the best practices for database access performance. And the way we will do this is by, the way we bring out the individual best practices is by looking at the AWR and ADDM reports. And this will help us understand the structure of these reports and what information is contained in these reports. And then we'll go about, through the reports, we'll go about identifying the problem and solving it. And that will result in the best practice that we would recommend. So here's a snapshot of an AWR report, and this is basically if you open up an AWR report, this is what you will see. This will be the first portion of the AWR report, and it has a various different statistics being presented, and these are in different currencies. I mean, the DB time is in seconds, and physical reads and physical writes. They are performing 0.2 reads per second. You have 102.4 hard parses. There are 51.1 log paths. So the thing to note here is that the most important parameter here is the database time, the DB time. The DB time actually is the sum total of the time that the foregrounds and the backgrounds use up in executing your operation. So this is the total time. So, and it is usually more than the wall clock time because you have multiple backgrounds and you could have multiple foregrounds which are operating on your workload. So it is the total time that the foregrounds and backgrounds spend in executing your workload. This includes any, if the foregrounds and backgrounds are performing an I/O, then it also includes the wait time. It does not include the time that the foreground is waiting for a request from the client or the middle tier. The whole goal of the primary goal of the performance tuning is to try and reduce the database time consumed by your workload. So through these reports, you will try to identify the main consumers of DB time. And once you identify those, then you would go through the process of trying to see how you can optimize those operations so that they end up using less DB time. So here if you see in this AWR report, we see that it's again ordered based on DB time. And in the same AWR report, you're seeing that the connection management time, it took 80.97 80.97% of the DB time was consumed by connection management. Clearly, this is very inefficient. So the workload is spending 80.97% of DB time connecting and disconnecting. And if you run the ADDM, you will see that ADDM actually goes through the process of looking at the top consumers of DB time and analyzing them and coming out with recommendations. So here it is coming out and telling you that there are the session connect and disconnect impact is 9.59 active sessions, and it is consuming 80.97% of the total activity. And it is also providing a action, investigate the logic to reduce the number of connect and disconnect calls. So ADDM in some sense will help you in not really having to go through the AWR report in more. I mean, there will be cases where you will have to inspect the AWR report, but in this particular case, ADDM was able to let you know the root cause of the problem. And the connection activity, I mean, clearly creating a database connection is expensive. It's expensive to create because when you want to create a connection, you go through the process of spawning a process. It goes through the process of creating your foreground process and network connection, and as part of authentication, you go through several round trips. So database connections are expensive to create, they're expensive to tear down, and repeated connection disconnection can be a huge scaling issue. So there are, in these drivers, we provide connection pooling features that you can use. Like if you're using JDBC, you can use the Java Universal Connection Pool. And just to highlight, you can go through the process of your code, go through the process of creating a connection pool. You can specify the minimum and the max size of the pool. And when you get a connection, you get a connection from the pool. And when you close the connection, you're not really tearing down the connection. You're basically going through the process of returning the connection back to the pool. So you end up sharing the connection resource across multiple threads. This is an example in OCI. I'll skip that. So there are cases where there are applications which have either they don't have connection pool coded in, or they do not have, or they have a process-based architecture. So if you have process-based architectures, and if you want to share the database connection across processes, prior to 11G, you did not have that capability. In 11G, we introduced a feature called Database Resident Connection Pool, which allows you to share connections across processes. Of course, we want to ensure that the session attributes in terms of the session credentials have to be the same for sharing. I mean, you cannot share Scott's session with John's session clearly. So we do all that check. To use the DRCP, all you would need to do is you would need to specify in the connect string, you have to specify pool, and this is not on by default. You have to enable it using the DBMS connection pool package, which provides you the start pool, stop pool. You can configure the pool. PHP, in the PHP world, because in the PHP architecture, it's all process based, so they're a big consumer of the database resident connection pool. Even if you have multi-threaded middle tiers, if you have the need that you want to share connections across your middle tier servers, DRCP provides you that capability. The changes that we have done in 12c is that we have provided 11g did not, JDBC driver did not support it in starting 12c. The JDBC driver will support DRCP. And we have also enhanced DRCP with ASO options, which was previously not available. So this is something new that we have added. We also have a feature called runtime connection load balancing, which works well in a rack environment. So you may have a connection pool with connections to different instances, to different rack instances. And when a request for a connection comes, which connection do you dispense? So using this runtime connection load balancing feature, when you enable this feature, the rack cluster is going to send us periodic advisories on the load on the various instances. So these advisories are being sent periodically to the middle tier, and using these advisories, we are able to figure out which instance is lightly loaded, which one, if we were to give a connection to that particular instance, your response time will be better. So this runtime load balancing capability is available in rack. So this is something new that we are introducing in 12c. So in rack we had this load balancing feature. I mean, today with the global economy, you have organizations having geographically distributed data centers of replicated databases. This is for the reasons of business continuity and disaster recovery. You are maintaining these globally distributed data centers. And in this kind of a configuration today, what happens is a client connecting to a primary, for example, may experience slow response when there is a high demand for the service that it is accessing on the primary. Even though there are replicas available which could have provided that service, today we do not have the same rack-like load balancing capability across these distributed databases. Also, if these databases are not managed by DataGuard, you do not have failover capability or centralized management capabilities. So what is really needed is a framework that automatically and transparently manages client workloads across replicated databases. And to do this, we are introducing in 12c a capability called Global Data Service. It's a new availability and scalability feature. And it is based on the two foundations of services and replication. So what it does is it extends the rack style dynamic load balancing and connect time load balancing capabilities to a globally replicated database configuration. Of course, when it is dispensing the connections, clearly it wants to favor a local server as opposed to something which is remote, which might have a big network latency. So we take that into our calculations in figuring out which is the best one to use. And we also, this one will automatically provide failover capabilities. So this results in higher availability via service failover, better scalability via multi-database integrated load balancing, and better manageability. A new centralized administration tool is being provided as part of this feature.
Want to take into consideration the performance differences of the different clusters?
Sure. So as part of the advisories, we do take that into consideration. So this graphically illustrates what this GDS is doing here. So you have two rack clusters with replication through Golden Gate, and you have the sales service. You do not have the ability to have a common sales service. With GDS, you are able to have a sales service which is a global sales service which spans all the databases in your system.
Why Golden Gate? Why not Data Guard?
Even Data Guard, it's supposed to, yeah, it's just an example.
Two-way replication?
I do not know the answer to that question. I can follow up.
So from an application stack, from an app standpoint, you're basically saying that I have a primary and it is replicated to the standby. From an app standpoint, if my connection to the primary goes down, then it will automatically fail over and establish new connections to
Right. Right. You would start, it would go through the process of, so basically it is using the standard failover capabilities that we have with both Data Guard and RAC today, right, on a global scale. So today the broker goes and tells the client that there is a switchover of the role. The primary went down, so now a secondary has taken over the role of the primary. So move your connections over to the new primary.
This is for rack, but if you don't have rack, you have a Veritas cluster or something.
Sure.
How does it?
So it also works with single database instances, so it doesn't necessarily have to be RAC. So coming back to the best practices, we talked about connection management. One of the other best practices is with respect to hard parsing. If you look at this particular AWR report, you will see in this AWR report there are about 920 hard parses per second. And if you run the ADDM report, or rather in this particular time model statistics also, you are seeing that the parse time elapsed is taking 90.55% of the database time, and the hard parse elapsed time is 79.96% of the database time. So clearly these are the top consumers of the database time. And if you run the ADDM, it comes back and tells you in the rationale, if you see, it's saying that at least 39 SQL statements with force matching criteria were found using literals. Look in $SQL, for example. So basically, it's pointing out that you have SQL statements with literals in your application. And if you have literals in your application, if you have SQL with literals, then every one of them will end up becoming a hard parse, right? You're not able to share the shared cursor, which is basically the compiled representation of a SQL, right? Because each of them are unique SQL statements. You end up not having the ability to share the shared cursor associated with a SQL statement. You have unique shared cursors for each of these SQL statements, and hard parsing results in the library cache latch contention, the shared pool latch contention, so it causes scalability issues. So the recommendation is to use bind variables. So it reduces hard parsers on the server, and also it reduces the risk of SQL injection. So if you were to use bind variables, then you would have one compiled representation, one shared cursor, that multiple SQL statements which are identical in all respects except for the bind value would be able to share. So that's the recommendation here. So this is an example of how you would do that in Java. So instead of using the generate number, the literal, you would replace it with a bind. And this is a bind variable example in OCI. So if you are not able to, there are cases where you are not able to replace your code, change the SQL to use binds, there is an option in the database, there's a init.r option called cursor sharing. And that cursor sharing value is, by default, it is exact. So if you were to set the value to force, then what it would do is it would basically force all SQL statements which are identical in all respects except for the literal value to share the same shared cursor. But so force also has some disadvantages in some cases. In one of the cases is that if you have two SQL statements which are using two different values, one of them could be the bind value would have been something that occurs very commonly in your table. So as part of execution, it might make sense to do a full table scan. Whereas there might be a case where for a particular value might not be occurring very frequently, in which case you may want to use an index. So by using force, you're basically saying that use only one shared cursor and one plan, which may not be the most effective way to do it. Similar tries to address that.
Is it certified with the e-business suite?
This is
Oh, like using force or similar? I thought we can only use exact for e-business.
okay. I'm not sure about that.
And also one more thing is, isn't similar going away?
No, I don't know.
If you have an application in which you cannot change the bind variables, and you have 70,000 literals, so do you want 70,000 shared cursors? And if some of them have bad plans, then it may make sense in that application to use force. So it's up to you to decide, and maybe eBusiness has a recommendation for that exactly.
Okay, so we resolve the hard parse issue by using bind variables. But in this particular AWR report, we are seeing that there's almost a one-to-one correspondence between the number of executes and number of parses. The parses it shows as 5,988, and the hard parses is 920. So the difference is actually what in our language is called soft parses, right? So what we are seeing is almost every execute is resulting in a soft parse. And if you run ADDM, again it is recommending that investigate application logic to keep open the frequently used cursors. So in this particular workload, what was happening was that the application was executing a statement repeatedly. But what it was doing was it would execute the statement and then basically close the cursor associated with it, and then go back and re-execute the same statement. So even though the compiled representation of the statement was available in the SGA, so you do not have to do a hard parse, you still have to do the work. The server will still have to do the work of doing some amount of parsing. You have to go through the process of doing syntax analysis and semantic analysis and do a lookup of the shared cursor. And that's the work that's happening in a soft parse. So the recommendation here is to use statement caching. And by statement, I mean like the drivers, OCI, JDBC, the ODBC drivers, the ODB.NET driver, all of them support a feature for statement caching. So that automatically the statement cache will cache frequently used statements. So you basically are holding on to the cursor when you return the statement back to the cache. And so subsequently when you re-execute the statement, you don't pay the price of a hard parse or you don't pay the price of a soft parse in terms of the syntax analysis the semantic checks. And also, there's also metadata being transferred as part of soft part, so we're also eliminating that. So this is a very, something that we recommend highly.
I have a question on AWR and ADDM. So AWR we runs on a regular basis every 1 hour. ADDM should be run on a regular basis or on the need basis only?
So you basically, again, with respect to AWR, again, you would, I mean, the process is you would first take a snapshot with AWR, and then you run your workload, and then you take another snapshot. So during the running of the snapshot, I mean, during the running of your workload, it is periodically gathering statistics during the run of your workload.
So what time ADDM should run? Because
So after you have generated the AWR report, that's when you would run the ADDM to basically go through, and ADDM looks at the AWR snapshots. It looks at the diff of the two and looks at the snapshot, analyzes it to identify the source of the problem.
so I'm not sure whether someone else noticed, but like when we were running ADDM, it was very resource intensive and it was generating a lot of high IOs. And it caused a slowness to the system, so we have to stop the ADDM. So I'm not sure whether other people notice those things or is that the issue?
This is happening with 11.203.
It was on 11.203.
Okay. Okay. I mean, if you can, we can
Yeah, if you can
get
talk
more
offline.
information.
I just wanted to
about it,
share with the
and,
audience,
yeah.
we had this issue.
Yeah, we can contact the appropriate groups and get back to you.
One question, is statement caching the same as session cache?
No, so actually I have a slide on session cache cursors. I'll talk about that. So this is statement caching in Java, an example of that, and a statement caching in OCI. In the interest of time, I'm going to skip over this, and I'm going to talk about session cache cursors. So in cases where your application does not have the ability to do statement caching, the recommendation is to enable session cache cursors. So basically what the server is doing is that when you close a cursor, it is basically putting that cursor in the session cached cursor. So that if you come back, if the application comes back and re-executes the same statement, then you'll try to look up. So you are trying to eliminate the soft parse cost by using the session cache cursors. But the session cache cursors are not as optimal as a statement cache because you're still paying the price of sending the metadata from the server to the client. So the network transfer and also all the processing still occurs with session cache cursors. And also if the application is actually tearing down its statement and recreating it, so there's also cost there. So first recommendation would be to use statement cache. If you cannot, then you can tune the session cache cursors. By default, it's set to a value of 50.
Is that per session?
It is per session, that's correct. So in 12C, we are introducing a new feature called auto tuning, and this feature auto tunes the statement cache. So primarily, if you have multiple sessions and dynamic workloads whose working set is changing across during its run on a daily basis, the size of the statement cache, if you have statically set it, may not be optimal. So if you have two sessions, and if one session needs 50 statements in cache at some point in time, and at a later point in time, it's not really using 50 statements, whereas there's some other session which really needs 100 statements in its cache, right? So by setting something statically, you are limited by the effective use of memory to allocate to the statement caches. So auto-tune is constantly monitoring the various activity in the system and tries to tune the statement cache so that you can get the best performance. So this is something that is new, that is being offered in 12C, which tunes the statement cache. Again, we can show that in the configuration file. All you would need to do is you would need to enable the auto tune to true. So by default, it's not enabled. So you will have to go through the process of enabling it, trying it out for your particular system. You can also, the other two parameters are optional. You can specify a RAM threshold. You can say that I want 0.1% of the memory that's there on this hardware allocated for the statement cache. You can specify a memory target also, so that it doesn't go unbounded in terms of tuning the statement cache sizes. So the next one with respect to best practices, with respect to bulk operations. So clearly in any distributed system, you want to limit the interactions between the systems, and so also between a middle tier and a database. So if you are doing any queries or DMLs, the recommendation is to try and do array operations instead of single row operations. And so single row DML/fetches incur excessive round trips. Again, the sizing of your array depends upon how much memory you have on your system. So some drivers like the PHP OCI 8 driver does not support array fetching. So we have this capability called prefetching. So that's a knob that we provide in this configuration file. So if you do not explicitly say I want to array fetch so many rows, but if you turn on this prefetching, on every round trip you would transparently prefetch some number of rows in the same round trip. So that's the prefetching capability that we have. So this is an Enterprise Manager snapshot. Again, Enterprise Manager also has things similar to the AWR report, more GUI based and more user friendly. And so here you can look at these screens and you can see that there were 7,955 rows being fetched, rows being accessed, and there were 796 fetches. So there are about 10 rows being fetched on every fetch. So by increasing it by a factor of 10, you can cut down on the round trip significantly. So that's the recommendation. So look at the AWR statistics, and if you are seeing that you're doing a number of fetches, but the number of rows you're fetching are limited, then you want to use array fetching. This is an array, again, same thing applies to array DML. So one of the things that we are introducing in 12c also is an enhancement to the array DML capability. Prior to this, when you executed for example, if you executed an update statement and wanted to update the salaries of employees in certain departments, department 1, 5, and 10, right? You wanted to update their salaries, and you want to know how many employees in each department got a raise, right? So prior to this, you would have to execute, after doing the update, you would have to go back and query each and every, for every department, you need to figure out how many of them got updated. But with this, in the same round trip, you can basically execute an update statement, and for each bind value, you can get back the row count that was updated. So that's the enhancement that we have provided. So the next one is network activity. Again, with respect to, if you want to minimize network activity, the recommendation is to use stored procedures so that you can perform your logic, so you can minimize the amount of data being sent back and forth. So that's one recommendation of using stored procedures. I'm running out of time, so I'll be skipping some of these slides. Client caching is another feature that we introduced in 11G. So if you have read mostly or read only data, if you are repeatedly accessing read mostly, read only data, the client caching feature, which was introduced in 11G, enables you to cache this transparently in OCI. And the advantage of using this feature is that this feature has the necessary smarts to figure out when the data in the server has changed. So if the data has changed, it will go through the process of invalidating the cache. So all of this is happening automatically for you. Secure files, again, this is something that we introduced in 11G. So if you have large objects, secure files is the next generation of logs. There have been optimizations done both on the server, in the protocol, in storage for using secure files. SDU sizes, we have increased the max SDU size to 2 meg in 12C. It was previously 64K in 11.2. There have been other SQL, PL/SQL enhancements. We have introduced 32K varchar and varchar2 and raw. We are providing native support for PL/SQL types like Boolean and records. We are supporting the ANSI identity functionality. Needed support to limit the rows written by a query. So there was one other high availability feature that I would like to talk about very quickly, and that's application continuity. So this is a new feature in 12C. If you have used transparent application failover tab, it had the limitation that you are not able to replay a transaction. So this one will go about replaying the transaction. So if you have a failure, we would be capturing the client captures calls issued by the application and replace the call on failure, including DMLs. So this is something that we are introducing in 12.1.
So this happens in database itself, or application has to be?
So basically this is actually happening in the drivers. So if you're using OCI or JDBC, actually this is, in 12C we are only introducing it for the JDBC type 2 driver, type 4 driver, the thin driver. So the JDBC type 4 driver is capturing the calls that are happening, it's capturing all the input values that you are providing. It's also keeping track of when the transaction was being executed, what was the result set that was sent, so that it will make sure that when you re-execute the same transaction, the behavior is the same. That is, it will make sure that you are getting back exactly the same results before it executes a DML. Otherwise, it will go through the process of aborting that transaction. So this is a very, it takes away the kind of the burden from the application developer to handle error situations.
If I may, there is a hands-on lab session. It's 12:15, HOL 992, and you can come and play with application continuity. There is a session tomorrow to discuss application continuity, and also if you come to the new JDBC UCP session, we're going to talk more about application continuity.
So that feature, if the transaction fails originally, the driver is keeping track of reinstituting that statement again if it failed. And this only is on rack, or is this on?
We cannot discuss packaging at this time. We're not allowed.
Okay. I'll give up.
His secret weapon?
Company policy.
And another feature that we are introducing is, this is called configuration. Another feature that we are introducing is called transaction guard. We have heard from customers who basically have this issue wherein they execute a commit, and then there are cases where the commit may have gone through or the commit may have failed. But before the response comes back to the client, across the network, the system dies. Mm-hmm. So now they'll have to the application has to keep some breadcrumbs to figure out whether the transaction really did commit or not, so that it doesn't have to duplicate the same order twice.
Okay.
So this transaction guard capability provides you the ability for, so what it does is primarily it introduces a notion of a logical transaction ID. So when you start a transaction, the client keeps track of a logical transaction ID. The drivers keep track of a logical transaction ID. Mm-hmm. And subsequently, when there is and each time the transaction gets committed, it gets bumped up. So in the middle of a transaction, if there is a failure, the application can go back and invoke a PL/SQL DBMS procedure to say, tell me whether for this, given this logical transaction ID, did this transaction commit? So you can go back and check and make sure that whether it committed or not. And once the answer is yes, the transaction is indeed committed. If it is no, the transaction will not, even if it's in a state of any kind of a flux, it will not be committed.
So the logical transaction ID is maintained at a session level?
Yes, it will be maintained at the session level. So the sample usage is if the database crashed, application gets an error. If the error is a recoverable error, you can get the logical transaction ID from the dead session and get a new database session, and you can call this get LTX ID outcome with the last transaction ID. So you can basically make sure that your transaction indeed committed. So this is how you would go through the process of enabling the transaction card. So on a service, you would enable the commit outcome, and then you can also specify the retention of that information, how long you want the system to retain the status of the transaction can be specified here. So high availability, we already have these features in 11G, the fast application notification feature, which basically allows you to get a asynchronous notification if your node dies, the network has gone down, you get back a notification. I mean, again, if you have a subsequent, if you have a different connection to a different network, you can get back that notification. So this is a asynchronous fast application notification mechanism. The TAF, like I said, is also an existing feature, but it only allows you to automatically do a failover and replay the queries. TAF will allow you to replay the queries, but not replay the DMLs or replay the transaction. That was the, in some sense, the
shortcoming.
We don't have the capability, the shortcoming of the feature. And with application community, we are beginning to address that shortcoming. And like I mentioned, in 12C, the OCI and OCI-based drivers are using ONS, the Oracle Notification Service, as the notification transport mechanism. Previously, we were using AQ, which depended on the database being up. So you would run into issues where in the last man, like if all the instances went down, with AQ transport, we were not able to get back a notification, but by moving to ONS, we are able to do that. And this is also scaling much better. So we are also seeing that. And we also provide automatic configuration of the ONS endpoints. If anybody is familiar with JDBC previously used ONS for its fan configuration, but one had to manually configure the endpoints of ONS. But with 12C, we have a notion of an auto-config. So again, you can just say auto-config to true, and you do not have to specify anything. Then we would automatically figure out the locations of the ONS servers that will be for this particular service, which are the ONS servers which are handling the fan notifications. But you can always enhance that by adding more information. So one other capability that we have added is this is more of an API enhancement. So whenever you get a database error, right? You executed something and you got an error, especially applications which require high availability, right? So when you get a database error, you want to know whether the operation that you performed is recoverable or not, right? Was the error because of the database going down, the instance going down, the node going down, or was it because you basically violated some constraint, right? So if you violated a constraint, obviously it's not a recoverable error. It requires changes to your application. But if it is a node going down, database going down, that's a recoverable error. So what we have done is we have added an additional status to the error handle. So again, like I said, it's an API enhancement to get you the error status. So in summary, When it comes to performance, we recommend using the best practices of connection pooling, using bind variables, using statement caches, trying to minimize network round trips by using features such as array operations, array fetches, and array DMLs. You can use stored procedures to basically minimize the client-server interaction. Usage of logs, using secure file logs is a recommendation. That's the next generation log. And if there is a need, if you are doing a lot of bulk operations, and if you want to increase the amount of data that is being transferred on your network round trip, SDU